Hello, my name is Andrew Restivo with group 74 of COP3530. We are the language masters with the dictionary and spell checker program.
Hi, my name is Darren Peters.
And I'm Adam Slavny.
And as Andrew mentioned, our problem is going to be involving a dictionary and a spell checker. So what we want to do is determine how the speed of a dictionary would be impacted by implementing it as a binary search tree, or more specifically an AVL tree in this case, and a trie. So the reason we kind of want to do this is because we know how a dictionary is with lots of words and lots of definitions full of information. Like the last time you've seen a handheld dictionary, it's thick. And what we're trying to do is find a more rudimentary way, I would say, of implementing a data structure that can take all this information in and spit it back to you just as fast as a normal online dictionary can, which tends to use things like maps, which are much better at saving a key and a definition. And so as stated, this dictionary is going to be able to spit back the definition of a word you input to you and check the spelling of the word in case the word didn't show up in the dictionary, or two, you just want to check the spelling of the word.
So the first part of this project is the reading of the dictionary.csv file and adding it to both the trie and the AVL data structure. As you can see, it took 2.6 seconds to add that dictionary of approximately 176,000 lines to the trie and 2.8 seconds for the AVL, making the tree 6.9% faster. On to the main functionality of the program. The two main factors that we are working with is finding the definition and spell checking a word. So before that, we have a help menu that outlines each instruction that this program takes, such as inputting a word, changing the mode between trie, AVL, and comparison. So onto an example. We are using the trie mode. And so if I search for dog, it'll return the part of speech and the definition, along with how long it took to find that definition using which mode. I can switch the mode using the numbers as stated in the help menu. Now in AVL, if we search for a word, we'll get the same thing, but a potentially different time. This happened to take 18 microseconds as well using AVL. The final thing that we can do is we can switch it to a comparison mode, which, let's say we search for the word test. It'll output a definition, and then also the time it took for using both modes, and then a percentage difference. So as you can see, to search for test, trie was 60% faster. Moving on to spell checking. This will take in a word, and if it's spelled correctly, like apple, it'll return spelled correctly, along with the microsecond time that it took for both modes. If we take a incorrectly spelled word, it'll return the correctly spelled word using the Levenstein distance algorithm. As you can see, for APPLF, AVL took 5.3% faster. For the correctly spelled word, the trie actually took 4.34% faster. There's other commands just like back and exit as well. So that is our dictionary program, and we are the language masters, and thank you for watching.